Introducing my class. All right, this is James Rumsey, Technical Institute, and we are live streaming out of Martinsburg, West Virginia. We are live streaming due to the corona epidemic, and we are attempting to do hands-on learning in our electromechanical technology class. Currently, I have Mr. Fogarty, who has signed in, Mr. Aversa, and Mr. Givens. All right. Thank you guys for your feedback here. I should have been trying to watch this, but I was so focused on what I was doing, I didn't see your messages come through. All right. So we have audio, and so we are now going to continue our development of our code. Now, last week, yesterday actually, we did the logic for our servos, and that was for our zone controls, right? We did just the logic. So let's go look at that logic, because what I want you to do is I want you to see, we're just going to review quickly what we did yesterday, and I'm going to bring that up. Let's go look over here. I'll bring it up on the screen. All right, I'm going to go open up the sketchbook, and we're going to go get the zone valve logic only. Okay, and here we go. That's our logic only, and I also will bring up the serial monitor, and then we'll split the screen so that you can see what that looks like. Okay. And I'll have that up momentarily here for you. There we go. All right. Let me bring that up on the screen. First, I'm going to walk through the code here, and then we'll put them up together. If we look at the code, this was yesterday's code. Remember, we just had everything defined, and we did our logic. And when we defined our logic, we used print statements everywhere where we were going to have actions by servos and so on. And as you can see here, we just put in open zone valve 1, close zone valve end switch. Now today what's going to happen here is we are actually going to put code in here because now that we have our logic straightened out, we can go ahead and put the other code in so that we're not confusing our code when we're trying to troubleshoot. Okay, so let's quickly see what this looked like when we did our switching. And so now I'm going to put them side by side, and I'm going to show the boards. All right, there we go. You guys should now see zone valve logic only, and it's waiting for input. Okay, and you will see how I did that in the code. All right, so I'm just going to set the code up here, and if on state is high and action 1 is high, we're going to say open zone valve 1. That's the message we should be seeing on the serial monitor when I go switch, and you'll be able to see me switch the little switch down here on the actual board. So let's go ahead and let's see what happens when I turn on. We should see the LED come on when I switch it. There's the LED. And we should see a message saying thermostat for zone 1 is calling for heat. Open zone valve 1. Close zone valve 1. End switch. All right. So let's turn it off and let's see what happens. Here we go. We're going to turn it off. The light should go out. LED goes out. And we should see a message that says zone 1 thermostat no longer calling for heat. Close zone valve 1, open zone valve 1, end switch. Now we're going to do the same for the second thermostat, and that is this little switch right here, and the yellow LED should come on. There it is, and we should see the message that says zone 2. Thermostat for zone 2 is calling for heat. Open zone valve 2, close zone valve 2 and switch. And of course, then when we turn it off, that will of course turn the light out, and there we go. And it says that zone valve 2 no longer is calling for heat, and close zone valve 2 and open the end switch for zone 2. Now, remember the LEDs that you saw, these were the LEDs. We're driving this with 24 volts, remember? And that's going into the optocouplers right here. Okay, there's our optocouplers. And so we're driving with 24 volts, and this is pulsating. This is AC, right? But because of the LEDs, it becomes pulsating DC that the optocoupler actually sees. Okay. So now that we've seen this, and you actually have audio going with it, the first half, guys, the first half of this live stream was for those of us who are hearing impaired, okay? And so those of us who are hearing impaired, that was a perfect video. We could see everything we needed to see. And now I gave the second section here for those of us who can hear, all right? Okay, so we're going to go on, and let's take a look at the code now. I'm going to go back to the code screen, and let's bring up the code for, let's see, we're going to now replace, this is now today, we're going to replace just the print statements with our actual code for the servo motors, and that's called zone valves operation code. Okay, so you'll find that on the G drive, of course, in the final exam section. Okay, and so now we have the zone valve operation code, and you're going to see it's exactly the same code, except notice what we added. We added the library for the servo. Right, there's the library, and we added in we defined the objects for these two zone valves, because we're going to control two servos, and I called them zone valve 1 and zone valve 2. Okay, that's our two servo motors. All right, just so it makes sense for us in here. And then of course this is all the same old stuff. We had that in there before. And you'll notice that I have added the zone valve ends, the zone valve positions. This is so that we know how far to turn our zone valves. And then I've put in the zone end switches so that we know which pin numbers and everything is for the relays. Okay, just like we had there before in our other code. Okay, in fact, it came right out of our test code, right? Because that's how we tested these things. So I just copied it right out of there. And let's see, what's in our void setup? Now, this is interesting. Our void setup, pin mode, I added the pins for the servos, right? Zone valve 1 attach on pin 6, and zone valve 2 is on pin 5, okay? And then you'll notice I did something right here. Let's take a look. I made sure that the zone valves are in the closed position, which meant I take them from 180 degrees open position, and I count down and I move them and make sure that they go down to 0, so they are closed right here in the void setup. It just happens once. I make sure they go to 0, and we'll watch that when we actually execute this code. Okay, and we run it. And then in our void loop, let's go see what happens. Remember where we said no longer calling for heat, And what did we add in here? Look what we did. So open, you see the serial print there. I still have it in there. You see the serial print statement. I didn't take it out. But what it tells me is it told me exactly where I needed to put my code for my zone valve. Okay? And so here I'm opening the zone valve. And then when I need to close the zone valve, hang on a sec, let's back up here a little bit. And then, of course, there's our serial print for the, remember we had that serial print there for open zone valve 1 end switch. Well, what do we go do? We just add the digital write for the zone end switch, and we send it high. Okay? And so that will turn on the end switch, right? But now let's see, open zone valve 1 end switch. Oh, I'm in the off position. Let's just go in here. I went down a little bit too far. There we go, but same thing. It's just, remember, we're going to an active low. Here we are. Okay, close the zone valve end switch. That's when we're calling for the heat. And we just added the digital write right there underneath the serial print. And so we know that it's happening at the right place because we've already done our logic. You see how we did our logic yesterday? And we just go put in the actual action that is now going to manipulate the actual electronics in the microcontroller. Okay? And so now we don't have to worry about, is our logic correct? We already tested that. Okay? So we've added this in. And then, of course, zone 2 there, I just put a note there, that was end of zone 1. And then zone 2 starts here, and it is identical to zone 1 other than we're looking at the components for zone 2. And so again, you'll see I'm just right there where my print statement was. All of this was missing in the logic code. I just added how to open the zone valve because I knew this is where it had to happen. Okay, and so I didn't have to look at this code to clutter up my view when I was wrestling with getting my logic straightened out for my code. Okay, and so you'll see this is just a repeat of zone 1. So I'm going to upload this and let's go see what happens on the actual board on our actual design. Okay, so I'm going to go to tools. I'm going to make sure that my correct, yes, I've got COM6 selected in my case, and we are going to compile and upload this code. All right, so let's go hit it. There it says compiling the sketch, and it should be uploading when it's done compiling. And let's go take, okay, so now that we've got that compiled and uploaded, I'm going to go ahead and show you guys the screen with the code, the serial monitor, and the 2 boards. And let's just go see what that zone valve board will actually do. Okay, and I think what we'll do is, yes, let me go to that picture. All right, and you should be able to see I've got the camera set so that you can see. I'm going to go point there to it so that you can see the servo motor. This is the zone 1, and that will be zone 2, and of course that will be the LED. So when we call for the heat, this LED will come on. The actual zone valve should open up, and in addition, we should see the end switch come on. So that's zone 2, this is zone 1. So we're going to go ahead and look at that. So I'm going to do zone 1 first, and let's turn it on, and let's see what happens. Okay, when I switch this guy on, there we go. Let's take a look. What happened? Oh, yes. That's wonderful. Let's take a look and make sure that our code uploaded and that everything is in good order. Let's make sure we had a successful upload here. It says it's done uploading. And let's see if my serial monitor is hanging things up here. Let me restart the serial monitor. Okay. Serial monitor. Okay, zone valve logic, waiting for input. Okay. And let's maximize that so you guys can see that. Okay. And I'm going to compile one more time here so that we can see what's happening. Alright, done compiling. Now let's make sure, yeah, it's the operation code. That should be there. And let's go see what's happening down here on the boards. I may have to make sure that everything is on. Yes, everything looks good. And, alright, don't see anything. Let's try zone 2. Ah, very good. Interesting. Let's see what's happened. Wonderful, guys. That's always good when you're doing a live demonstration. Let me reset a few things here and make sure that everything else is good. I'm just going to cycle my power off here. Alright. Hopefully my zone valves didn't... I heard there was a noise this morning and I wondered what it was. I might have lost one. Let's go see what this other one looks like. Let's see. Okay. Well, it looks like my zone valves have decided that they're not going to work right now. And that is a shame. Okay. Anyway, I will have to take a look at that. In fact, this is a good time to just troubleshoot. And let's go see what is happening. If you guys will give me just a moment, I'm going to go get a zone valve just to go check and see. Well, just out of curiosity, let's go see what happens here. Does the solenoid valves actually come on? The code is saying closed zone valve, open end switch. Looks like that is all good. And and if I turn it off, let's see. A closed zone valve 1 and open zone valve end switch. Now the interesting thing is, it looks like we got a power failure because my relays are not coming on either. And so that is very interesting that they are not coming on, because they should be independent of the zone valves. It's just a matter of coding. And so let me try that again for zone 1, and the zone valve should have done its thing, and it definitely looks like we have a power failure somewhere, and we will check that. That means that the 5 volts coming from the Arduino here on the other board may have failed, and that definitely looks like it. Let me see what's happened there. Okay, guys, now it's time for our meter. Well, this is good. I'm going to go ahead and back the camera out so we can do a little troubleshooting. Alright, this will be good. Let's put this in here. And so what we've got is this. Let me zoom out a little bit. Okay. This Arduino, even though it is on, doesn't seem to be putting out the 5 volts on the 5 volt bus. And so that's going to be the test that I'm going to do. I'm going to get a jumper real quick, and let me just see here. I'm just going to take a quick jumper and pick one up over here off my chair. Okay, and I'm just going to check the relay board. Remember, we got this relay here. I got two inputs here that I can take low, which we're not using right now. And if that doesn't go low, then it means we don't have 5 volts. And so let's go ahead. I've got 2 test wires here. I'm just going to go to the relays we're not using. And then, of course, we know we want to ground that. And I am grounding it right there. Oh, and look, we are actually working. So we got 5 volts, okay? See that? So we know, okay, that's not the issue. So the issue is our Arduino here must not be working. And I wonder if this Arduino decided to go and pick daisies. We're going to double check that, because how can we do that, guys? Let's remember, this is now the 2 wires that are controlling the relay board over there. So if we should ground one of these, we should see that come on. So let's go ahead and troubleshoot. I'm going to pull this one out here. This is for number 1. It's pin 3, and I'm just going to ground it. Oh, and look at that. Our relay there is coming on, which means we have a situation with this Arduino. Now, I'm doing this kind of on the fly here because this was unexpected, that everything was working so nicely this morning and yesterday. So what are we going to do next? Okay, we're going to need to now troubleshoot the Arduino board. Okay, and so I'm diverting now from what should have happened a little bit, but this is excellent because Murphy always says when you're working on a project and there's a deadline, something is going to happen, isn't it? Okay, so let's check it out. So I'm going to go and let's go to a better view. Instead of the 4 boards or the 2 boards together, I'm going to go to a full board view here so that we can see what are we going to do next, okay, to troubleshoot this. And I'm going to use a combination. We built some test code. What a good time to load some test code, okay? I'm going to go ahead and pull up the code for the test code, and let's see what you guys, okay. Yeah, Mr. Gibbons, you laugh, and you've been there, done that, I know. You've had your share of this nonsense. So I'm going to go ahead and say File, and let's go get the sketchbook. And what are we going to load? We're going to load our test code. This is why the test code is so cool. Let's go get the zone 1 end switch test. Okay, let's do that one first. The zone 2, and then zone valve. Let's see if we got the end switches. Let's see, zone 1 and zone 2 end switch test. Let's bring that up and let's upload that. Okay, let me bring that code up for you so you can see what it's going to look like. Remember, let's bring this up here. Here we go. Okay, here's the end zone code. And all that's in there is the 2 end zone is the relays. We're going to start with them. Okay, we're going to test the relays right there. Okay, and then let's see what happens. Zone 1 end switch output, zone end switch high, and we just turn it on and off, right? So let's go see if that works. Let's upload that. All right, we're compiling, uploading, and done uploading, and let's go take a look and see if something is happening. Let's go take a look at our picture here, and let's see. Oh, look at that. Our switches are actually working. Okay, pretty slick. So now you see the value of our test code. Okay, I could have spent the rest of the morning just troubleshooting what the heck is going on and guessing here and guessing there, but quickly load our test code and everything works. Now, I'm going to go ahead and load the other test code for the servo motors, right? Let's go do that and see if that helps us out any. All right, so I'm going to go back to code. We're going to go get the file, sketchbook, zone, and I'm going to use the simultaneous. Oh, let's do the sequential, one and then the other, so that in case one of them is bad, we'll see which one it is. All right, so here we go, and I'm compiling the sketch and uploading, and let's go ahead and see. Okay, I see something happening. Let's go look at our motors, and let's go take a look. There you can see the at least zone 2 is working. Let's go show you that zone 1 is working, and so that is working. All right, there you can see there's zone 1 and there's zone 2. Okay, that is awesome. So look, you know, as far as our board wiring and everything and motors, everything is good. So this points to something that's going on in the code. That was a nice surprise because it was working a few minutes ago. I must have hit something by accident in code and clobbered it, but let's go take a look. But you see what the value of our test code is. All of a sudden I know, hey, it's not a board issue, and so I can safely say, you know what, that is awesome. And just for a final test, let's go load up these two simultaneously on the zone valves, and I'm going to compile that, and you just watch the motors here, and they should both start working together here momentarily. There we go, and let's see, done uploading, and there they go, they're working together. So I can comfortably say and confidently say that, look, the wiring is okay, the motors are okay. Now let's go see what did I clobber in my code, okay? And so I'm going to go ahead and close out the test codes, zone valve and switch tests. But I think this was an awesome, even though I didn't plan on it, an awesome event that you can see the value of the test code. And so now I'm going to go back to the zone valve operation code, and let's go see what in the world went wrong over there. And how do we go about testing that now? Because obviously the zone valves and everything that we have there, everything should have been working. So I'm going to just go ahead and, just for the sake of, just recompile, because it's possible that with everything that we shut off and so on, that it's resolved itself. So I'm recompiling the code right now. And I think everything is going to be all right. It says zone valve end switch contact closed. Okay, it initialized. Let me go back to this guy so you guys can see. I'm going to go ahead and clear the output on the serial monitor, and I'm going to go ahead and recompile, and let's watch that serial monitor, and let's see what happens. Okay, I hear something. Thermostat zone called for heat. Open zone valve 1. It actually did what we needed to. It called for the heat. The zone valve is on, and guess what? So obviously the Arduino board needed to be shut down and restarted, and so everything is working fine. But you see how quickly we were able to troubleshoot that by just using our test code. Okay, now let's go back. Let's go take a look. If I right now we've got the zone valve 1 is on, the end switch, you'll see the light is on, and yes, it did close the contact because this is our input to our aquastat, right? So if I turn this thermostat over here off, let's watch this zone 1 motor. It should close. There it goes, it's closing, and when it closed, the end switch turned off, which opened the contact, and our aquastat input is now off. Let's turn that one on again. There we go. All right, and there we go, and it's off. Okay, and let's do number 2. Okay, there we go. It's on, it's moved, and there our aquastat opened, and let's turn it off. Okay, and our zone valve is closing, and the end switch, of course, turned off, and the output is closed. Woo! Nice. I'll tell you what. Murphy had his finger in this one. Oh, yes. That is glorious. But we recovered thanks to the test code. I didn't touch anything, guys. All I did was load the test code and then reload the other code. Don't know. Can't explain it. That is the world of microcontrollers and the world of electromechanical technology. Get used to it. You're going to find this in the field. Don't get frustrated. That's the key. Don't get frustrated. This was a classic example of what if you were in the middle of doing a presentation at your interview, or you were doing something. Don't get flustered. Systematically, if you use the methodologies we were learning all year, systematically go back and start troubleshooting, correct? You saw what I did first. I went to a hardware level where I jumpered directly on the solenoid board to ground to see if the board was working. It was working. Then I loaded our test code, okay? And so everything tested out fine, and then when I reloaded the code, everything worked the way I wanted it to. Show you this morning how we added in our code. All right. Now that was for the zone valves. Now the other thing I'm going to show you today is the aquastat, and we're going to go through that because this one is a little more hairy. And this is specifically why we want to use that methodology of the logic first, okay? So now we're going to work with the aquastat side of the project, okay? And I'm going to go ahead and load that code. So I'm going to switch here so you guys can see. All right. I'm going to go here and I'm going to go get that code and sketchbook, and that is the aquastat aquastat logic only. Okay. Now, before I start with this logic, you're going to say, Mr. Armour, where did you come up with this logic? Okay, and Mr. Givens asked me on a couple of occasions. He said, Mr. Armour, what are the requirements for the aquastat project and the zone and so on? Now, when we started this project, remember we had just finished boilers and so on, and I had told you that, remember, we had two pictures, the aquastat picture, wiring diagram, and the primary control. Remember the primary control schematic? That's in that Word document in which we had for our initial wiring of this project. You can go look at that. And if you analyze that wiring diagram, you can extrapolate the logic, which is what I did. I just went to look at the wiring diagram and then I did the logic. However, for your convenience, and because you are still learning, and I know, it's a daunting task sometimes to do this, what I did is I also have a Word document, okay? So I created a Word document, and let me just go see. I called it, let me go to my screen here so you can see what I'm navigating. I'm in the Corona class folder. I'm going to go to that folder, Corona class folder, And let me actually do this so you guys can see what I'm looking at. Hold on a second. I'm going to switch to another screen and slide this over to there, where the writing would be a little bit bigger for you guys, so you can see what I'm navigating. Let's take a look here. I'll get it just for a second. Alright, let's go see. Alright, now, let me get this slid up here. Alright. Close that out. And let's bring this up to that drawing here. Okay. Interesting. Let me just, guys, this is what happens when you're working with multi-screens and gives you grief. There we go. Let it decide which one it's going to go to. All right. Okay. Okay, we're almost there. It's marvelous. I tell you what, technology is killing me today. That's all right. We'll get there. Let me size this way down, and then I can drag it over there. There we go. Come on, oops. Getting there. There we go. The beauty of live streaming. Alright, doesn't matter how much you practice. I practiced this all this morning, and now everything's gone to hell in a, what do they call it, in a basket. Alright, let's go see here. Okay, we're almost there. Okay. Oh yeah. Oh yeah. There we go. Now we can see what we're doing. Okay, now it's a little better. How's that, guys? Okay, now you should be able to see. Let me do one more thing here. There we go. All right. So I'm in the Corona class folder, and I created a Word document, and it was called Week 40, Day 3 Final Exam Requirements. Now I'm going to open that up, and let's see where the hell it's going to open up, on which screen. And then hopefully it comes up on the right screen. If not, I'll get it there for you. Oh yes, look at that. Must be living right. Okay. I'm going to go ahead and let's make it a little bit bigger. Okay, there we go. And we'll expand that out for you as well, so that you can kind of see where things are. All right. Okay. So in this document, you'll see the requirements of an aquastat, and I'm just going to go through that real quick, and then the primary control requirements, so that you can see what we're doing in our code. And the two zone valves, which is the one we just finished, let's look at that. The two zone valves, each zone valve will turn 180 degrees, representing movement from closed to open. Zone valves will activate an associated switch at the end of a 180-degree cycle when the valves have reached fully open position. And then the zone valves will deactivate an associated switch at the point at which the valve returns to the closed position. Zone valves will be activated by a thermostat for each zone valve, represented by a input switch. All right? So that was the requirements of the zone valves. Okay? Now let's go look at the aquastat. All right? And let me see if I can get that to be just a little bit better still for you guys. Okay, right about there. And let's see if I can up the zoom there for just a little bit. Okay. And then let me see if I can just slide my mugshot out of the way there for you. There we go. All right. So let's read what that says. Okay, the aquastat is the circulator pump will come on when the aquastat is summoned by the zone valves and if the boiler temperature satisfies the low limit requirement. Okay, now where did I get that sentence from? Well, I extrapolated that out of the PDF file of the aquastat, which means if you go look at the wiring diagram, the logic diagram of that aquastat that we were using, that is what the original wiring of the aquastat was doing. It said, look, the circulator pump will come on when the aquastat is summoned by a zone valve or thermostat, and if the boiler temperature is above the low limit requirement, okay, the low limit of the setting of the aquastat, then the circulator pump will come on, okay, and so that is one of the requirements. If the low limit requirement is not met, which means the boiler is not warm enough, the circulator pump will remain off, even though the end zone valves are calling for it. The circulator pump will stay off until the boiler gets to that low limit temperature, and so it will stay off until the boiler temperature is at and above the low limit threshold. The aquastat will then summon the burner to come on if the boiler temperature is below the high limit minus the high-low threshold setting. Okay, now on an aquastat, you notice there was that setting that we played with before that was the high-low threshold. Now let's talk about that. That is the temperature differential. They call it the temperature differential, which means once you've reached your high limit on the boiler and the boiler shuts off, if the boiler temperature drops, at what point do you want to fire the boiler again? Well, that's adjustable on the aquastat, and we can set that in our code that we're going to develop. And so the burner, so our requirement says the aquastat will summon the burner to come on, and if the boiler temperature is below the high limit, which is the highest limit, okay, that's a setting on the aquastat, the aquastat will summon the boiler to come on, okay, and it will stay on until we get to that high limit. The burner will stay on until high limit is reached. The burner will turn off after the high limit is reached, and then will remain off until the temperature drops below the high limit minus that high-low threshold. Okay, remember that threshold I was telling you about, that temperature differential setting. That so if I set it at 10 degrees, it's going to have to drop 10 degrees below the high limit before the boiler will kick back on. Okay? And then it'll fire again. And then it'll go back to high limit, shut off, and then if you're circulating water, that water in the boiler has to cool down 10, 15, 20 degrees, depending on what our temperature differential is set at. Okay? So that is the requirement. I got this straight off the wiring diagram of the aquastat. Okay? Now, let's go take a look. That's how the aquastat functions. Now, let's go see what the primary control does. Now, remember, the primary control is the control that said, that was the one, you remember when we had the burner? I had the burner up on the table, and we looked at we took out the electrodes, and we looked at the high voltage transformer, and we had that little box on the side that was the primary control. We did a wiring of it and so on. The logic for that is at power on. Okay, so let's look. At power on, check the light sensor and make sure there is no flame. So remember, when we looked at how that thing operated, if I exposed the CAD cell to light and I turned that unit on, the primary control will not allow the system to turn on, period, because it says, look, this thing showed me light when it's supposed to be dark. When I turned on, I'm not going to do anything. Well, our code needs to do that as well. So at power on, check the light sensor and make sure there is no light or no flame. If startup light sensor reading is good, then allow the primary control to initialize, otherwise trip the system. Okay? Now, on call for heat, so when we turn this thing on and we're calling for heat from the aquastat, we're going to proceed to turning on the boiler. We're going to call for boiler and ignition and fuel solenoid to come on. Okay, so when our end zone switches calls for heat, we're going to have to get this thing to turn on for us. Okay, if the call for heat from the aquastat, okay, so it says there, let me highlight that, on call for heat from aquastat, proceed to turning on the burner, igniter, and fuel solenoid. Okay, count process cycles for 15 seconds and then check to see for light, which means if there is no light after 15 seconds of firing the burner, if no light, set the trip and shut down the burner on the solenoid. Do not allow the reset except through total process reset, which means I have to restart the system just like we did on that primary control in order to start up. So that's our requirement. You see how I extrapolated the requirements. After ignition process cycles off, after the initial process cycle of 15 seconds, check for light. If the light is off for 15 seconds, kill the burner, which means if I didn't get ignition, kill the burner. All right? So that's how the primary control works. Okay? So I made this for you guys so that you can, as you develop your logic now for your aquastat and primary control side of this project, which is what you're going to do today and tomorrow. Again, we're just going to work on the logic first, and I'm going to show you an example. I did that, and we'll see how that works, okay, and how it looks. But this is the document that has that requirement in there for you. I'm going to close it. Okay, let me close that out. All right, and so let me go ahead and check and see everything's still good, guys. You can give me a thumbs up if everything is good at this point, because we're going to go look at the code for the logic for this aquastat. And so I'm going to go ahead and get that loaded. Let me go ahead. I'm going to switch here and file sketchbook aqua. Let's see, motor aqua solid. Let's see, aquastat logic only. All right, aquastat logic only. There we go. And we're going to go ahead and take a look at that. Let me just see how things are going here. All right, I got a thumbs up from Mr. Givens. He said, thank you for the document. You're welcome, Mr. Givens. Okay. And so I'm going to go ahead and I'm going to switch. I've got that switch there for you. Here's our code. And let's go ahead and look at that a little bit. All right. And I'm going to slide it over. Yeah, we can see that. All right. So this is the aquastat logic only, and I'm going to change a comment here. Aquastat logic only. There we go. And heck, we'll put in today's date, which is the 20th of May. All right, and in progress, do not use. Well, we know you can use that. Okay, so here we go. Our aquastat, we know the input was pin 12. And again, I took this now from our test code. I just pasted these in here. The aqua switch start millis, sample duration 500. Okay, I put in all my inputs and so on. And then I put in a bunch of stuff here in regard to flags and everything that I'm going to need. Okay, you guys can go through. You'll see these are all statuses because I'm going to use these. You'll notice messages, all different boiler messages, because remember when we in class, when we did our serial monitor, that serial monitor would run through your screen, and you'd have to shut it and stop it and see what was going on. And so in here I've got a mechanism for you that you'll see in the code how you can control that serial monitor so that it doesn't just continue to run up on through. So I set messages or message statuses that says, look, if the message status is low, then print the message, and when I'm done printing the message, I immediately set that to high so that the next time through the loop of the main loop, it won't print it again until something has changed and I need to reprint it. Okay, and you'll see how that is done in the code. But let's go ahead and take a look at this code real quick. I'm just going to cycle through just a short section. Now, I broke it down into a couple of, it's actually broken down into 3 sections. If you looked at the requirements and when you look at the actual aquastat functionality in the original wiring diagram of the aquastat in the PDF, which is the data sheet for that aquastat, you'll find that the circulator pump is controlled by the thermostat input or the zone end switch connection to the aquastat. And the actual function of that circulator pump only depends on 2 things. It's the thermostat and the boiler temperature, which means if the boiler temperature is not good and the thermostat is not calling for heat, then the circulator pump is not going to come on. That's it. And so it doesn't look at anything else. So that's an easy thing we can do. We can say, look, go check it out, see what happens, write the code for it, and see what in the world's going on. Okay? And so that's one little piece of our logic we're going to write in our code. The next piece is the actual boiler temperature. The boiler temperature really doesn't care about the thermostat. It doesn't care whether you're calling for heat or whether you want to circulate or not. All that part of the aquastat does is it looks at the boiler temperature and it looks at the high limit, the low limit, and it looks at the, in fact, it doesn't even look at the low limit for that matter. You'll see. The low limit is there for the setting telling us what temperature the boiler needs to be at before we can circulate, which means that first circulator, we said, looks at the thermostat. The thermostat says, I need to circulate, give me some hot water. The aquastat says, well, I see that signal. I'll turn on the circulator pump provided that my boiler is above the low limit temperature. Okay? So the low limit has to do with the circulator pump. The heating of the boiler looks at the high limit and the temperature differential. That's all it looks at. It says, look, if my boiler is not at high limit, I need to heat this water. And once I get there, I will cool down to the temperature differential that is set before I come back on and reheat the boiler back to my high limit. Okay? And so it just repeats doing that, and it just makes sure that the boiler is hot and ready to roll. And that's all that part of that circuit does, and the logic. Now, of course, knowing that it needs to heat the boiler, that's the signal that it gives to the primary control on the burner, which means once the aquastat tells us we need the boiler, the burner, or we don't need the boiler, that's the signal we're going to look at to determine what the primary control is going to do in our logic. So that's what I've broken down our code into. Okay, so let's take a look. The void loop, you'll see I jumped over the void setup there because it's just a matter of setting up our inputs and outputs and making sure that the solid state relays are all turned off. Okay, the circulator, you'll notice there. Let me go look at the code. I'll bring a code up for you here. Here we go. Let's take a look here. The void setup has the pin modes. It says the aqua switch is an input, the burner motor is an output, the ignition coil is an output, the fuel solenoid is an output, and the circulator motor is an output. And then we have, of course, our trip LED is an output. And then we digital write and make sure that our motor and our coil and solenoid and circulator motor is off. And remember, it's active low, so we need it high to be off. Okay, now let's go see what the main loop looks like. Okay, and there's our circulator code, starts here, and I'm just going to quickly go through and just show you the section. So I said circulator code starts here, and we go through, and it's the same as our test code. We've seen this, the on state, off state. We're looking for that 24 volts coming in or 5 volts, but it doesn't matter whether it's pulsating or not. We got that handled. And then we decide to turn on circulator pump here if it calls, if boiler temperature. Ooh, look at this. Now we look at our boiler temperature, right? You see that? On state. We'll come back to this. I'm just going to show you the sections for it. So here's our circulator pump section, and there I put a note in, end of the circulator code stops here. But we continue on, and now our boiler status code. This is where the boiler is looking at the high limit and temperature differential to make sure that the boiler is hot. Okay, that's this section. And I again put a comment for you. Boiler status code ends here. Notice that's a comment I got right here for you. Okay. Now, primary control code starts here, which means if the boiler status there needs for the burner to come on, this is the code we got here. Primary control code starts right here, right after the boiler status code ends. And this section of code is, all it does is determine what is the burner doing. And of course, that is where our CAD cell, you see there's our CAD cell looking to see what's happening, and this follows the requirements of that system. Not a whole lot of code, guys. Actually, the logic is what's tricky. And that's why you notice I've just got my serial prints in here. I don't have anything here to turn on the burners. All I did is I'm doing print statements, and we're going to go test that and see how that looks. Okay, because you know, we need to look at this. So I'm going to do it in sections. So I'm going to just work with the first section. I'm going to show you the first section, which is the circulator code. Okay, the circulator code. And what I'm going to do is I'm just going to go ahead and comment out everything below it. All right. So let's go do that. And the circulator code stops here. All right. And I'm going to put a little, you guys saw this before. the little slash with an asterisk, and everything below it gets commented. But now I got to be careful. I got to go down, and I got to go all the way down here to the end, because if I don't go get my last bracket, if I don't go get my last bracket at the end of my code for my void loop, then I'm going to have an error. Okay, so I'm just going to go right down here, and I'm going to say right here, let's end that asterisk there, and you'll notice that my end bracket has highlighted, and if I go there, that should now line up with my void loop at the top, and we're going to go look at, make sure, and sure enough, everything is cool. And if I now compile, I will be compiling just this portion of the code to where it says circulator code stops here. All right, and so everyone cool so far. I'm gonna put a comment in here. Everything good to here, and I'll put a question mark, and you guys can give me a thumbs up in case there's questions. Okay, so I'm going to compile this, and now, of course, I'm going to quickly go and switch. Let me go ahead and get you a picture here of the boards, because I'm going to have to switch my cable from my Arduino board, from the zone control to my Aquastat board. So just to let me shift this camera for you guys so you guys can see what shenanigans I'm pulling here. Okay, I'm going to take my cable from my computer that's going to the zone control Arduino, and you notice it stays on because of the switch and my power supply over here that is coming through my isolation diode. Remember, we have an isolation diode right here. Let's go take a look. There it is. All right, you see that little guy right there, and my little switch. This is my little switch here that will switch on and off this zone control Arduino right there. Okay, that's my zone control Arduino, and here is my Aquastat Arduino. So now I'm going to bring my cable, and I'm going to plug it into here so that I can do my programming for my Aquastat, right? And so now we are going to kind of focus on here, because I'm going to let you guys see when we start putting in, because I'm actually going to control this from the I'm actually going to control it from the thermostat zone control board. I'm going to turn these guys on and look for this input as I write my code to make sure that my logic is correct here. All right, and so we're going to see what happens there, because I want you guys to look. I'm going to be playing with this little guy to get my low limit set for my circulator portion of my code. I'm going to be looking for that value. Okay, so let's go ahead and do that. Let's see, where's the comment here. Everything good to here? Okay, Mr. Givens said yes. Thank you, Mr. Givens. All right, so let's compile this. Now, of course, I got to go up here before I can compile. Let's see. Good Lord. You guys have no idea what I was doing over there, because my picture, let me just get that back up here. Oh, it should be okay. It looks like everything was okay there. Let's go see what's happening there. All right, so we are at the, I'm going to put the code up. Yeah, you can see the code. I'm going to go ahead and make sure that I have the correct port selected, because I remember I switched now, and here is COM7, and I can now compile to my board. And remember, I'm only compiling the code that I highlighted. The rest is commented out because I only want to work with the logic for that circulator pump. Okay, that's how I developed it. I started with one section, then I added the second, and then I added the third, so that I didn't confuse myself developing my logic. Okay, all right. So let's go see where we're at. Okay, let's look here. Done uploading. All right, so let's go back to that little screen so you guys can see that. And I'm going to bring up the serial monitor, and let's see what that looks like. Just get that up there for you guys. All right, serial monitor COM7. All right, you notice it's a blank screen. All right, and let's see what happens based on my code. Let's go look at this code again, and let's see, what do we anticipate. So if I get right now, if I call for heat, turn on circulator pump here. So if my on state, if I get pulses and the boiler temperature is greater than the low limit, okay, you see that there. Let me highlight that. There we go. If it's greater than the low limit, and I'm using a map statement, I'm analog reading the boiler temperature, which is my potentiometer, and I'm mapping it to 50, from 50 to 240 degrees. If it's greater than my low limit, now my low limit is something that if we had a bunch of potentiometers, we could have set those all up as settings, but I put a variable representing those settings. If you look over here, I have a high limit, a low limit, and temperature differential. So my boiler has to be at 160 degrees before I'm going to circulate any water. Okay, my high limit is 210 degrees, and my temperature differential for the high limit is 20. But I'm just worried about this low limit right now, 160. If my boiler is at 160, I can circulate if they call for heat. And if they don't call for heat, or if I call for heat and the boiler is below 160 degrees, the circulator is not going to turn on. And that's what we're going to go test now. Is our logic correct? Okay, so let's go look at that. So here it is. Let me just set that logic up here for you. Okay, get through the inlet. There's our main loop. There we go. On state equals high, boiler. So if the on state is high, because we've read the pulses, and our temperature is above our low limit, turn on the circulator pump here. Circulator status equals high, and if on state equals high and the temperature is less than low limit, then do not turn on the circulator. Set the circulator status to low, and then we say the same thing. We go read if we don't get pulses, we turn off the circulator pump here, and everything is turned off. Okay, so let's go see what is going to happen here. And you notice that there is a if circulator status is high, all that good stuff happens here. And we should see some results. Okay, so let's go see what happens if we start flipping some switches. And I'm going to just compile here for the last time here, make sure everything is cool. Compiling, uploading, and we should be in good shape there for our done uploading. I'm going to go ahead and watch. You can watch now. You should be able to see me turn on the actual switch. Okay, and I'll make sure that the camera is such that you can see that. Yes, you should be able to. I'm going to just slide it just a hair over so that you can see the switch. There we go. All right, so let me. I'm going to first turn the temperature of the boiler down to a low temperature, and I'm going to turn on this switch here, and my zone valve goes, and there we go. We see the light coming on, and let's see what we got. I didn't see anything. Okay, well, good Lord, it's doing really well. Doesn't even look like my code's running, but we do know that because something should have happened here. Let me reset this once and let's see. Okay, all right, let's see. It's almost like the code isn't being sent to the let's go take a look here. Let's compile one more time. Okay, uploading, and I'm wondering whether it's uploading to the right. Yeah, it should be uploading. Done uploading. Okay, it's very interesting because I'm just looking to see when it says compiling sketch uploading. Yep, it's uploading on the board. Okay, and I don't see anything happening on my serial prints. Let's see, turn off circulator pumps here. Okay, should be okay. I'm gonna go ahead. You guys see I'm doing code here. Let's put in a serial print statement right in the initialization that will say waiting for, just so that we know that something is happening. Okay, so I'm going to go ahead and put in a serial dot println open parentheses, open brackets, and I'm going to say ready to run main loop. Okay, and I'll close the parentheses and there, and we'll put that, and I'm going to compile that, which means if this is working on my void setup, I should see a message coming up on my serial monitor, and let's see if that happens. Okay, if that doesn't happen, then we know we got something going on. Let's go see. Okay, it's compiling, it's done uploading, and ready to run main loop. Okay, so we know that the Arduino is running. Now let's go see what in the world is going on as to why it would not do anything else. Void circulator code starts here. If digital read switch equals high, let's go make sure that I'm going to create that just so we get something happening. I'm going to move this little code here, Control X. I'm going to copy it out of there, and I'm going to say let's put it in right over here, Control V, because I want to go see is my main loop running, and then we can go see why we're not seeing the signal coming in from the system. Okay, and let's go ahead and compile, and we are compiling, uploading, and let's see. Now we should just get a bunch of messages that show. There we go. So we know the code is actually looping. Okay, and I'm going to go ahead and let's go switch and see if anything else has happened here since then. It's interesting because the end switch, okay, is actually closing. Um, there we go. End switch is closing. And it's turning on and off. And I'm going to look here and see if anything else. Now I'm going to turn off the serial print statement again because I want to see is anything else happening. In fact, I'm just going to move it down to see if I'm going to show you guys. I'm going to take it and I'm going to cut it and I'm going to put it inside the digital aquastat equals high. So if digital read aquastat equals high, I want to see did I read a high, okay, when that light turns on and off. So it should only print if I get a high, okay. And so let's go see if we get any of that. I'm going to compile that one more time here and let's see what happens. Because again, this worked very well and now it's not working very well, and so that is so very awesome. Let's go take a look and see what's happening. All right. It's amazing what Murphy will do. Let's go ahead and see. Our serial monitor isn't doing anything because I moved it. Now, just out of curiosity, I'm going to just clear the screen there so that we can actually see. I'm going to go ahead and clear the serial monitor so that when we do hit the switch, see if anything happens. All right. Okay, we've cleared it, and I'm going to go over here, and you guys should see me with my finger here on the switch. I'm going to call for heat, and there we did. So we did read the main loop, and so we know that we are getting input. Okay, now let's see if the rest is happening. I'm going to recompile. I'm going to take out my little test serial print here, and for right now I'm just going to comment it out because I might need to move it down here in a minute. All right, I'm going to recompile, and let's see if this thing has started to work here. In the meantime, this is the craziness of the beautiful Mr. Murphy. And I'm going to clear my monitor. All right, and let's go see why it is not putting anything out on the screen for us. Okay. All right, I've closed it. Oh, you know what? You know why nothing is happening? That is because my boiler temperature is cold, okay? And I didn't put a message in there for that. Let me up the boiler temperature and let's see if anything happens. Oh, there. Turn on circulator pump. All right, look at that. Now let's turn. What I did is I moved the boiler temperature up to be above the 160 degrees, okay, that we were set at, okay. And so now let's look what happens here. Okay, I'm going to turn off. There we go. Turn off the circulator pump. Now you notice that you saw how I did my troubleshooting, okay, because I realized that by the time this was happening, the real issue was that my temperature was too low and nothing happened, which means when I called for heat, should the circulator pump have come on? No, because it was cold. The boiler was cold. And so now we know that the boiler is hot enough because I cranked it up. When I call for heat, there we go. There is the call and turn on circulator pump. Now you notice it doesn't say zone 1 because the circulator doesn't care. It's just turning the circulator pump on. The zone valve determines who gets the water, right? The zone valve, you noticed over here, I'm going to turn it back off. The stepper motor, let's look at that here so you can see it. Let's see, yes. All right, right there. The stepper motor, there goes the light, and now the zone valve is open. When it got to the end, let's see if we can see that over here. Yeah, okay, if you look at the relay here, when I turn this off, There goes my servo, and it's stopped, and this turned off. The zone valve opening determines where the water goes. The circulator just knows it needs to pump. And that's why if you look at the serial monitor, the circulator pump is coming on and it's going off. Okay, I'll turn it off. That's going to turn off. Let's see. Yep. It says turn off circulator pump here. All right, so our logic is working. And we know we cranked up our boiler temperature here on the potentiometer so that we had enough boiler temperature. Okay? And so that is what should happen there. What happens if we turn on zone 2? There goes our zone valve, and there we call it, and turn on circulator pump. All right, so the pump is on, and we can turn it back off. And let's see what happens here when we turn it back off. There goes our zone valve, turned off, and it says turn off the circulator pump. And so just to prove now, I'm going to turn this back to cold. Let's make the boiler cold again. And I should have put a message out there to show the temperature. But anyway, okay, there it's off now. I know it's below the 160 degrees. And when I turn and call for heat, I'm just going to hit zone 1. It's going to come on, and you notice that the serial monitor, nothing happens. The circulator is still off. Okay, so that is my portion of the code that deals with the circulator. Now, okay, so what's going to happen next is we're going to go into that code. Remember, we commented out. I'm going to turn on the next section of code, which has to do with bringing the boiler up to temperature. Okay, so we're going to do the logic for the boiler. Okay, temperature, that portion of the aquastat. So I'm going to switch back to the big screen on the code, and that way you can see I'm going to go down in my code, and remember, in fact, I'm going to take out this little test code I had in here that I was just using to troubleshoot there. Couldn't figure out what was going on. It was 1 o'clock this morning when I finished this code, guys. Okay, so here we go, and if aqua switch count is greater than 0. Okay, that was still the circulator there. All right, we're coming down, and there we commented out. Remember, there's our little comment point. I don't know if you guys know that this single stroke with an asterisk comments everything below it until you end with an asterisk and a single stroke, and anything then in between those two sections will be commented out. So I'm just going to move this little guy. Okay, I'm going to Control X, and you notice this turned back on. Ooh, look at that. And I'm going to go down, and now this is the boiler status code. Is going to go here, right? The boiler status, getting the boiler up to temperature. I'm going to go to the end of that section. Okay, go to there. Boiler ends here, and I'm going to put that little doohickey, the slash and the asterisk back in here, so that everything is back off below it, because I'm not ready for the primary control logic yet. Okay, so you see that's blocked out, but my main little end of my main loop, that is good. It's after that it's back on. Okay, so I'm just commenting out this gray stuff in here, and now we're going to look at this portion of the code here, where it starts with my status code for the boiler. Okay, the boiler status, temperature. Okay, and we notice it says, look, if the boiler is greater than or equals to the high limit, then we're going to clear some boiler messages over here, and boiler message 1 equals boiler message 1 plus 1, because I set it to 0 in initialization. This tells me I need to print a message, And then if the boiler message is 1, I'm going to tell you what to do there. Boiler hot status equals high. Serial print boiler at high limit, no burner needed. Okay. And boiler on status needs to be low because we have reached the point that where we need to be, and that will tell me later on to turn off. So if boiler message is greater than 2, then boiler message equals 2. Now I do this so I don't want to just keep counting this up, because if nothing has changed and my boiler is still at temperature, I don't want to see this message just continuing on. But at the same time, I don't want my counter to keep counting up a big number, so I just set it to 0 or to 2, and it always stays higher than 1, so I only see this message once. Kind of a little trick there. You'll see what happens. Boiler else, if boiler message, which means if it's not higher than the high limit, which means if my boiler is not at high temperature, I need to do a bunch of stuff. And here we go, and we start and we say, look, if it's less than the high limit, turn on the boiler. Okay? We start the boiler, and there's my message to turn on the boiler, and there's my little thing, so it only prints it once, and we go through. And then, of course, if it gets up to temperature and it is above the high limit and temperature differential, if it's within that little window of temperature where I don't want it to go, we turn off the boiler there, because we've got to wait for it to cool down low enough to get below that threshold, that 20 degrees below the high limit. Okay, and that's the end of that boiler status. Okay, so here is where we say, look, if it's less than the high limit minus our temperature differential, which means if we set our high limit at a 210 degrees and we got a 20 degree temperature differential, then there's going to be 190 degrees. We've got to drop down to 190 degrees before we can turn on the boiler again. And that's where we do it right here. There's our if statement for that. Okay, and we'll print this message. And you notice it's just print messages until we get our logic, and then this is what we're doing now. Next week, okay, I'm going to let you guys work. I'm going to give you today and tomorrow to wrestle with this code to get your circuits to follow the logic. Now, it doesn't have to be this exact code. You can write your own code. This is purely if you need some extra help, this is available to you. All right, but let's go see, and I'm just showing you how to develop your logic without trying to turn on the burners and everything else. All we're doing is print statements at this stage. Next Monday is where I'm going to be throwing in the, in fact, is it next Monday? It's next Tuesday, because Monday is a holiday, right? So next Tuesday is when we will throw in the actual, in fact, let me get this up here. Next Tuesday is when I'll show you, we'll throw in all the actual code for turning on the lights and so on. And then on Tuesday and Wednesday you can get that done so that you're all set by the end of next week, because the end of next week is essentially the last live stream, and we'll have this all wrapped up. Okay, so I'm actually going to see if I can get this done for you guys by tomorrow, even though, remember now, tomorrow I may have a late live stream. You guys can tell me here in comments whether you want to live stream tomorrow or whether you just want to work on this. What I'll do is I'll get the rest of the code in here to show you just how I added the real code to actually turn on the guys. Once my logic here, you see my logic here is all set today. And then what I may do is just make a video that you guys can watch anytime. You don't actually have to come and watch the live stream. I'll actually create the video and then just post it for you guys to watch. Unless you want a live stream, you guys can indicate that in the comments for me, okay? All right, I'm going to go back here to the code now, and let's go take a look and see where we're at. We're ready to go test some code here. I'm going to go ahead and go back to our screen where we can see the boards and the code and the serial monitor, and I'm going to clear that, and I'm also going to recompile now based on commenting, bringing in this code here that I uncommented. Okay, I'm just going to compile one more time, and let's see what happens. Okay, our serial monitor says turn on boiler status for boiler here. Okay, you notice that our boiler temperature is cold. It's only 94 degrees. Remember, that's where I left it when we were testing the zone, the circulator pump. Remember, when it was cold, it didn't circulate, right? So you notice that our serial monitor says turn on the boiler, turn on boiler status for boiler here. Boiler temperature is there is 94, and our high limit minus temperature differential is 190 degrees. Okay, so I'm gonna, when I put in my actual code to turn on the boiler, I'm gonna turn that boiler status on because we are cold. Okay, and so let's go ahead and crank it up a little bit. Okay, I'm just going to go ahead. You'll see I'm cranking up the potentiometer here, and let's see what happens when I get up above the 160. You're not going to see that until I hit the 160, and then you'll see the print statement come up. And let's go take a look. And actually, I'm going to have to go all the way to 190. Let's go see what happens. In fact, I'm going to have to go up all the way to 210. Okay, because I'm heating. The boiler status is, it says, look, you're cold, you need to run. And the aquastat is not going to change the boiler status until I get to a high enough temperature where, there we go, the boiler high limit was met. Okay, which meant I cranked up the temperature until the boiler got to the high limit and no burner is needed. Okay, so when my boiler temperature, I cranked up my potentiometer until my boiler temperature got high enough and the high limit, no boiler is needed. Now, the next thing that we know that we should see is if I go and turn that potentiometer back down, the temperature of the boiler is going to drop down, but I want to, you notice the boiler limit, no burner needed, which means we've shut off the burner now. The boiler's hot at 210 degrees or higher, and because we met the high limit, now you notice I'm turning the potentiometer down, and let's see what happened. The boiler temperature is 209, okay, and I'm sitting right on the threshold there, so I'm going to crank it down a little bit more, and it said boiler temperature 200 high limit minus temperature differential, which means I'm below the high limit, but I'm above the temperature differential of 190 degrees, which means the boiler is going to turn off. The boiler status for burner here. So turn off boiler status for burner here. So now the boiler says I'm hot, but I'm going to stay off until the temperature drops below 190 before I come back on. So I'm going to go ahead and turn this potentiometer down, and let's see if that indeed happens. So I'm going to turn this down, and when we get to below 190, there we go. Boiler temperature is there, and turn the boiler back on. Okay, so we don't go all the way down to the low limit because the low limit is purely for the circulator. Okay, so the temperature differential is where we dropped below, and now the boiler status is back on for burner. Okay, so my logic there is good to this point. Just all in messages, nothing else. I'm not doing anything with turning anything on and off for real. That is going to happen when we that's going to happen when we put in our code for that, because there's no point in putting all that stuff in and cluttering up our code while we're wrestling with logic. So we test our logic first. We'll write a code just for our logic. All right. Now, let's go down here and let's go see. So now that we've got this logic, all that is left is for us to put in the boiler status code. Okay? And so let's go see what happens when we take this little piece out of here. Okay, I'm going to take that out of here. All right, that's taken out of there, and it pops back on. So let's just, I'm going to get that back on the screen here for you guys so you can see what I did. Okay, all right, I took out, remember I had the little forward slash and a asterisk there. You see it. This is the primary control portion now. That's the part I want to go put back in. So I'm going to take that in. And now, just for the sake of I don't get myself in trouble, I'm going to take that little guy out on the bottom here that I had in. I'm going to take it out as well because I don't need it anymore. All right, so now all my code is turned on, and now I can test the actual primary control portion of it. So let's go see what happens. Now that's where the burner, I'm going to make sure that my boiler is cold so that it calls for heat, because what's going to happen is we're going to go look at some things now. Remember, the primary control is now where we're going to look at that CAD cell, which is the photo or light sensitive resistor and all that part of our circuit. And that's where the trip is going to occur. So in order for that to happen, I'm going to go ahead and compile this, and immediately it should go into a condition where once it's compiled, because my light is off, I don't have enough light on, and it's not totally dark, it's going to say, look, I didn't see dark, but let's go see what happens when I compile this. Okay, all right, I'm compiling, uploading the sketch, and let me, I should clear it, there we go. Burner ignition fuel valve here, fire the burner, and so it was dark enough there for it. Let me go clear, let me just go clear that, and let me compile one more time. Okay, so it's actually seeing enough light. Let's go see what it does. Let me show you guys the dual screen there with everything on it. All right. Turn on boiler status for burner here, boiler temperature. Okay. Let's see. That was the part there. Fire burner ignition fuel valve here. All right. And system tripped, burner ignition fuel, so turn on trip LED. All right, so you notice it tripped there because we needed boiler. You see the boiler status, turn on boiler status for burner here. The boiler temperature was at 186. The high limit was 190, so we were below that, and so it needs the boiler. But because you notice on the camera there, let me move the camera out a little bit so you guys can see where the little CAD cell is. In fact, I'm going to set it so that you can zoom in on that a little bit, because I'm going to show you what I'm going to be doing. Okay, there's light. Okay, and because I started the code with light, not bright light, but just light, like I opened up I lifted the coil up. Remember when I had it on the table here, I lifted the coil up and the CAD cell is exposed, so that it gets some ambient light. We don't want that thing to be able to say that's valid, and so we've addressed that here. So I'm going to put my finger over this CAD cell, and let's see what happens when I do a reset now. Remember, I've got to do a total reset, so I'm hitting the reset button. Okay, and let's see what happens. see what happens on startup. Anything? Nothing, right? Okay. Let me hit it one more time. Okay, in fact, there we go. Okay, burner. It said turn on boiler status for burner here, and it's dark. I'm going to take my finger off, and there's still just ambient light, and we should still get a trip because I'm not firing. The boiler isn't firing. Oh, look at that. We tripped on the trip LED because and we should turn on the trip LED there. Now remember, it's not, the LED is not going to turn on today because we're just putting in our messages. But that's what should happen, right? The trip LED should come on and we shut the burner down. That's because there was no light yet. It's just ambient light. The flame wasn't there. So I'm going to do this one more time, and remember that took 15 seconds. Watch, I'm going to put my finger back over it. Let's do it one more time, and let's just hit the reset. I'm going to reach up there. What I'm doing, guys, is I've got one finger up here on the reset right there. So that's what I'm doing. In fact, why don't we zoom that out just a little bit so you guys can see what's going on. Okay, there we go. So I've got my finger over the CAD cell here, and I'm doing my reset. There we go. I've hit the reset, and there we go. Fire burner, ignition, and fuel valve here. I'm going to take my finger off, and I'm going to hit light on it. Okay, and at this stage it should stay on. Okay, and 15 seconds, and sure enough, the boiler is on. Fire the boiler here. Fuel valve is on. Everything is on. The light, the flame is on. But if I lose my flame, let's go see what happens. If I lose my flame, okay, I've taken the light away. You can see the bright light went away. 15 seconds, we should get a trip condition. Okay, let's see if that happens. There we go, and we've tripped the system, and if I bring the light back, it shouldn't matter. We are tripped, and we can't do anything until we've done a reset. Okay? All right, so we've met all the conditions of the primary control. Okay? And so the code that is there, go through this code. It's there for you. Go through the code and look and see what we did, and that will give you a little bit of an idea of what needs to happen before we can now connect. You notice I didn't put any of the code in to turn on the lights because there was no, or to turn on the burners, you know, that the little lights that's representative of the burners. So that's what I'm going to do this tonight, and I'll make a video then in the morning just showing you the code, and I'll put the code out there for you as well, which will be called, this one's called the Aquastat Logic Only, and then the other one will probably be called the, and I'll put that in the video, the final name for it, but probably the Aquastat run code, okay, which will have everything in it to turn on the lights for the burners and everything else in the circulator, and then we should be able to run the entire system, including the second, the zone control. We'll run the zone control and the Aquastat system together, and all the lights and everything should be working by the end of tomorrow. And then that is then available to you for next week. So what's going to happen next week is, okay, Monday, I believe Monday is the holiday, and so I'm not going to live stream Monday, but Tuesday, Wednesday, and Thursday, I'm going to Zoom. We're going to do Zoom sessions, and that's going to be Zoom sessions for you to show me where you are having, if you're having problems. Look, if everything is working, then our Zoom session is, I'm just going to check out your boards and see and get excited in watching all your boards working. So that's what I look forward to seeing on Tuesday, Wednesday, and Thursday. And I'll be there to be able to answer some questions for you live on Zoom, looking at your boards and so on, if you have any of those kind of questions. All right. So let me see what the comments is. Everything good? Okay, John Givens. I'd love to take tomorrow to work on this. Yes, Mr. Givens. Like I said, you can take tomorrow. I'm going to create the video with the rest of the code, and I will post it tomorrow. But you can watch that anytime during the weekend. I'm just not going to live stream it tomorrow. Okay, I'm not going to be on live streaming, but the video will be there for you. Okay, so that you have everything that is in the code that you need. Okay, so that should work for you guys. Any other questions, guys? I'm looking at your comments here. I know today was a long session, but you notice there's the code is not that long. It looks long, but when you go through it, it's more because I'm spouting off here that makes it long. The code is really not that much. It's very little code, and I don't think it's that difficult. The only part that is maybe a little touchy is how I manage to control the serial prints to the serial monitor, so it only happens once when it needs to happen. Okay, and that way the screen doesn't just keep rolling. It actually just steps it up as the different conditions happen, and you'll see how that was done. Okay, so I'm going to be looking here for your comments just to make sure that everything is cool. And so if you guys can all give me a thumbs up there that everything is cool, we can call it a day. Okay, so I'll be looking for your thumbs up here. Just give me a thumbs up. All right. All right, I'll just give you guys a few moments there. I know that everything happens here for a good reason. And if I trust that the camera work was clear enough for you to be able to see everything that needed to be seen. Okay. Okay, I got a John Givens thumbs up. Okay, Mr. Versa, if you're in there, Mr. Fogarty, if you guys are in there, if you can just give me a thumbs up, we'll call it a day. All right. Okay. All right. I don't see the thumbs up there, but I don't see a thumbs down either. So I'm going to call it a day, guys. If you have any questions, you can text or email me, and I will be glad to answer your questions. Okay, so I'll go ahead and close out our session with the normal screen indicating that our class today was the zone valves and the coding. All right, we'll see you guys.